completed the introduction of IIR filter and the information related to direct form 1 and 2 in the previous class. So now let us start with the problems related to direct form 1 and 2. The question is, what they have done is they have given us the transfer function of the filter h of z, and they are asking us to find out three things. The first one is, does this h of z represent a FIR or IIR filter? So what we should do, with the help of the given transfer function, we need to tell whether it is an FIR or an IIR filter. In the second question, they are telling us to find out the difference equation, and they are telling us to draw the difference equation using which form? Direct form 1. So moving on to the third part. So in the third question also, what they are telling us to do is, they are telling us to find out the governing equation, which is nothing but the difference equation. Then with the help of that difference equation, I should draw direct form 2. Okay. Now starting with the first question, that is, I need to find out whether it is an FIR or an IIR filter. We all know that if it is an FIR filter, the transfer function of an FIR filter contains only zeros. So looking into the transfer function, if the transfer function contains only zeros, then such kind of filters are called as FIR filters. So coming to IIR filter, if the transfer function of a filter contains both zeros and poles, then such transfer function belongs to IIR filter. Now I took the given transfer function, so and I have simplified the transfer function. So this is the transfer function which we get. So looking into this transfer function, in this equation we have both zeros as well as poles, okay, the numerator part as well as the denominator part. Therefore, looking into this, we can tell this given transfer function belongs to which type of filter? It is an IIR filter. So what is the conclusion for the first question? That is question A. Therefore, it is an IIR filter. Why it is an IIR filter? It is having both zeros as well as poles. So this completes first question. Moving on to the second question, what they have done is, they are telling us to find out the difference equation, and then they are telling us to draw it using direct form 1 structure. Let us start with second question, that is question B. So for that I will rewrite h of z. So what is h of z? We know it is nothing but equal to y of z by x of z. So this is equal to the given transfer function, that is 7z square minus 0.25z plus 1.375 whole divided by z square minus 0.75z plus 0.125. Now what I need to do, I need to reduce this transfer function to find out the expression for y of z. Then with the help of the expression of y of z, I need to find out the reference equation. For that, I will take z square as a common factor in the numerator and z square as a common factor in the denominator. So if we do so, the equation will be z square into 7 minus 0.25 z inverse plus 1.375 z power minus 2 whole divided by z square into 1 minus 0.75 z inverse plus 0.125 z power minus 2. Now in this expression what I can do, I can cancel z square and z square. Now let us rewrite the expression for h of z. So what is h of z? H of z is nothing but equal to y of z by x of z, which is equal to, what is the equation? It is 7 minus 0.25 into z power minus 1 plus 1.375 into z power minus 2 whole divided by 1 minus 0.75 z power minus 1 plus 0.125 z power minus 2. Now from this expression, let us cross multiply and let us try to find out the expression for y of z. So if I do so, I will multiply directly. Y of z into 1 is y of z minus 0.75 into z power minus 1 into y of z plus 0.125 z power minus 2 into y of z. This is equal to, cross multiply x to this term. So, it will be 7 into x of z minus 0.25 into z power minus 1 into x of z plus 1.375 z power minus 2 into x of z. Now, I wanted the expression for y of z. So, keeping y of z in the left hand side, let us move rest of the terms to right hand side. Therefore, y of z will be equal to 7 into x of z minus 0.25 z inverse into x of z plus 1.375 z power minus 2 into x of z. Move this term towards right hand side. So, minus 0.75 z inverse y of z becomes plus. So, I can write it as plus 0.75 z inverse into y of z. Now, moving plus 0.125 z power minus 2 y of z towards right hand side becomes minus 0.125 into z power minus 2 into y of z. Okay. So, we got the expression for y of z. Now, to this expression, let us start applying inverse z transform. So, apply inverse z transform to the above equation. So, if I apply inverse z transform to this, I can rewrite the expression as y of n, which is equal to 7 into x of n minus 0.25 into x of n minus 1 plus 1.375 into x of n minus 2 plus 0.75 into y of n minus 1 minus 0.125 into y of n minus 2. Now, I got the expression for y of n. What was the question? Give a difference equation realization of this system using direct form 1. So, in order to draw the direct form 1 for the given transfer function, we needed difference equation. Now, we found out difference equation. With the help of this difference equation, let us start drawing direct form 1 realization. I got the difference equation. Let us start drawing the direct form 1 realization. Here, y of n is our output, x of n is the input. So, let me start with x of n. So, x of n should be multiplied with 7, and it should be given to an adder. Then, the second term is x of n minus 1, that is nothing but delayed version of x of n. So, delay x of n once. This gives us x of n minus 1. X of n minus 1 should be multiplied with minus 0.25. Multiply this with minus 0.25. Give it to an adder. Connect the output of this adder to the top adder. So, we completed the first term and the second term. Moving on to the third term. So, this is nothing but the delayed version of x of n minus 1. So, if I delay x of n minus 1 once, we get x of n minus 2. So, x of n minus 2 should be multiplied with 1.375. Multiply this with 1.375 and connect this to this side. Okay. Now, if I chuck the output at this adder, so the output of this adder will be 7 into x of n minus 0.25 into x of n minus 1 plus 1.375 into x of n minus 2. That is, we completed 3 parts. Okay. Now, at the end what we do? We get the output. So, here we get the output. So, coming to the fourth term, so y of n minus 1 will be the previous output. So, delay y of n once. gives us y of n minus 1. This should be multiplied with 0.75. So, multiply this with 0.75 and I should connect it to an adder. Now, connect this adder. Now, connect the output of this adder to the top adder. Okay. So, only I took one more adder here. Okay. Now, this is also done. Looking into the last term n minus 2, y of n minus 2 is nothing but the delayed version of y of n minus 1. So, delay this once gives us y of n minus 2. Y of n minus 2 should be multiplied with minus 0.125, then give it to the top adder. Okay. So, did we complete all the figure or all the terms? Yes, we completed all the terms. So, this is nothing but the direct form 1 realization of an given IIR filter. Okay. We completed the first and second sub questions. Now, let us move on to the third questions where the given transfer function should be used, and with the help of that transfer function I need to find out the governing equation. Then with the help of governing equation I should draw which structure? Direct form 2 structure. Moving on to the last question, what I have done, I have written h of z. Now in direct form 2 what I do is, we know h of z is nothing but y of z by x of z. Let h of z be equal to y of z by x of z into w of z by w of z. So, if I rewrite this, I can rewrite this as w of z by x of z into y of z by w of z. Okay, where this is nothing but our h1 of z and this is nothing but our h2 of z. So, if I write h1 of z, h1 of z will be equal to w of z by x of z, which is equal to 1 divided by the denominator value 1 minus 0.75 into z power minus 1 plus 0.125 into z power minus 2, and the next term is h2 of z, which is equal to y of z by w of z. So, which is equal to only the numerator expression, that is 7 minus 5.125 into z power minus 1 plus 1.375 into z power minus 2. So, if I combine z1 and z2, if I take the product of z1 and z2, we are going to get what is h of z. Now, with the help of this, let us start finding out the governing equation. For that, first let me consider h1 of z. So, h1 of z is nothing but equal to w of z by x of z, which is equal to 1 divided by 1 minus 0.75 into z power minus 1 plus 0.125 into z power minus 2. Now, in order to get the difference equation, I need to find out the expression for w of z. For that, let us cross multiply. So, if I cross multiply w of z minus 0.75, I am multiplying it directly into z1 into w of z plus this into this term, that is 0.125 into z power minus 2 into w of z. This is equal to x of z into 1. Yes, x of z. Now, I should find out the expression for w of z. So, let us move rest of the term to right hand side. Therefore, w of z will be equal to x of z plus 0.75 into z power minus 1 into w of z minus 0.125 into z power minus 2 into w of z. Clear? Now, we got the expression for w of z. With the help of this, by applying inverse z transform, I can get the expression for w of n. For that, let us apply inverse z transform to the above equation, w of z can be written as w of n, which is equal to x of n plus 0.75 into w of n minus 1 minus 0.125 into w of n minus 2. So, this is the expression for h1 of z. Okay. We got the first governing equation. Now, I need to find out the second governing equation, that is with the help of h2 of z. So, we know h2 of z is nothing but equal to y of z by w of z, which is equal to 7 minus 5.25 into z power minus 1 plus 1.375 into z power minus 2. Now, here I need to find out the expression for y of z, then with the help of the expression of y of z, I can find out y of n, which is nothing but our output equation, that is the difference equation. So, for that let us cross multiply. So, y of z will be equal to 7 into w of z minus 5.25 into z power minus 1 into w of z plus 1.375 z power minus 2 into w of z. Clear? Now, we got the expression for y of z. So, in order to find out the expression for y of n, what we should do? I need to apply inverse z transform to this expression. I have written the previous difference equation. Now, to this I need to apply inverse z transform. So, if I apply inverse z transform, the expression will be y of n, which is equal to 7 into omega n minus 5.25 into w of n minus 1 plus 1.375 into w of n minus 2. So, what I did? We applied the inverse z transform and we got two different equations. Now, let us start drawing the direct form 2 structure with the help of this expression. Here the input is x of n and the output is w of n. So, take x of n, okay. X of n is multiplied with 1, give it to an adder. Then if I add all this, the output what I am getting is w of n. Okay. Moving on to the second term, w of n minus 1 is nothing but the delayed version of w of n. So, delay this once, gives us w of n minus 1. To this multiply 0.75, to this multiply 0.75 and give it to an adder. Connect the output of this adder to the top adder. Okay. Now, we completed the second term also. Moving on to the third term, it is nothing but the delayed version of w of n minus 1. So, delay this w of n minus 1 again once, gives us w of n minus 2. Multiply this with minus 0.125 and give it to an adder. Give this to an adder. So, we completed this equation. The first part is done. Okay. Moving on to the second part, here the output is y of n and the input is w of n. So, w of n is here. I will write it here. So, w of n is here. Now, w of n is acting as input and y of n is the output. So, w of n should be multiplied with 7 and it should be given to an adder. Multiply w of n with 7 and give it to an adder. So, if I take all this terms and give it to an adder, we are going to get the output y of n. So, what is the second term? W of n is delayed once. So, delay this w of n once, it gives us w of n minus 1. To this w of n minus 1, what should I multiply? Minus 5.25. At this point, we get w of n minus 1. To this, I should multiply minus 5.25. 2, 5, and I should connect this to an adder. Connect the output of this adder to the top adder. Clear? So second term is also done. Moving on to the third term, again it is the delayed version. So delay w of n minus 1 once gives us w of n minus 2. That should be multiplied with 1.375. Multiply this with 1.375 and connect it to the top adder. So finally you will get what is y of n. So what is y of n? Y of n is nothing but the entire combination of these two equations. So this is how we can draw direct form 2 structure. So this is our direct form 2 structure. So like this, if they give us the transfer function, we can judge whether it is an IIR or an FIR filter. Then we can start deriving the difference equation and start drawing direct form 1 and 2. The second problem is they have given us the transfer function and they are telling us to draw df1, which means the direct form 1, and df2, which means the direct form 2. Taking transfer function, if I start deriving the difference equation, let us take z cube as the element in the numerator. So what is left out? 0.28 into z power minus 1 plus 0.319 into z power minus 2 plus 0.04 into z power minus 3. Similarly, if I take z cube as the element in the denominator, common element, so z cube is moved outside, so the left out term is 0.5 plus 0.3 z power minus 1 plus 0.17 into z power minus 2 plus 0.2 into z power minus 3. Now we can cancel z cube with z cube. So what is left out? Therefore, h of z will be equal to 0.28 into z power minus 1 plus 0.319 into z power minus 2 plus 0.04 into z power minus 3. So in the denominator, what is left out? It is 0.5 plus 0.3 into z power minus 1 plus 0.17 into z power minus 2 plus 0.2 into z power minus 3. Here. Now what I should do? I should start drawing direct form 1. For that, we all know h of z is nothing but equal to y of z by x of z. So in the next step, let us cross multiply and write. So if I cross multiply and write, it will be 0.5 into y of z plus 0.3 into z power minus 1 into y of z plus 0.17 into z power minus 2 into y of z, and finally it is 0.2 into z power minus 3 into y of z. So we have cross multiplied the denominator term with the numerator term on the right hand side. Now let us do the numerator term with the denominator term. So this will be equal to 0.28 into z power minus 1 into x of z plus 0.319 into z power minus 2 into x of z plus 0.04 into z power minus 3 into x of z. Now I want the expression for y of z. So let us move rest of the term towards right hand side. So the expression will be 0.5 into y of z, which will be equal to 0.28 into z power minus 1 into x of z plus 0.319 into z power minus 2 into x of z plus 0.04 into z power minus 3 into x of z minus. So from this terms I should move towards right hand side. That becomes minus 0.3 z power minus 1 into y of z minus 0.17 into z power minus 2 into y of z minus 0.2 into z power minus 3 into y of z. Now we got the expression for y of z. Now I need to find out y of n. In the next step, let us apply inverse Z transform to this. So apply inverse Z transform to this equation. So I can rewrite the expression as, so the first term will be 0.5 into y of n, which is equal to 0.28 into x of n minus 1, and the second term is plus 0.319 into x of n minus 2. The third term is plus 0.04 into x of n minus 3 minus. So what is the next term? So it is nothing but this one, that is 0.3 into y of n minus 1. The next term is minus 0.17 into y of n minus 2, and the last term is minus 0.2 into y of n minus 3. So now I want only y of n to be in the left hand side. So let us move 0.5 towards right hand side and let us see what is the equation for y of n. After moving 0.5 towards right hand side, so this is the expression for y of n. Here we know y of n is nothing but the output, x of n is nothing but the input. If I start drawing the direct form 1 realization starting from input x of n. So if I look into the difference equation, do I have x of n term? No, I don't have. It is starting from x of n minus 1. So for that what I can do is delay x of n once gives us x of n minus 1. So this x of n minus 1 should be multiplied with 0.56. So multiply this with 0.56 and give this to an adder. Connect this adder output to the top adder. Clear? And then if I look here again, x of n minus 2 is nothing but the delayed version of x of n minus 1. So delay x of n minus 1 once, again delay this once, gives us x of n minus 2. This x of n minus 2 should be multiplied with 0.638. Multiply this with 0.638, give it to an adder, connect the output of this adder to the top adder. Clear? Now what is the next term? That is the third term. It is x of n minus 3. So for that what I should do? Delay x of n minus 2 again. Delay this once, gives us x of n minus 3. Multiply x of n minus 3 with 0.08 and connect it to the adder. Clear? Now we completed the first part. Now I should move on to the next part. For that, so connect the output of this adder to the next adder. So finally if I add rest of the terms, I get what is y of n, which is our output. So moving on to the fourth term, here y of n minus 1 is nothing but the delayed version of y of n. So what I should do? Delay this y of n once, gives us y of n minus 1. Multiply this with minus 0.6, connect it to an adder, connect the output of this adder to the top adder. Clear? So next element is y of n minus 2. Delay this once, gives us y of n minus 2. Multiply y of n minus 2 with minus 0.34 and connect it to an adder, connect the output of this adder to the top adder. And the last element is nothing but y of n minus 3. So delay this again, gives us y of n minus 3. Multiply this with minus 0.4 and give it to the top adder. So this is nothing but our direct form 1 realization of an IIR filter. Okay. So the standard structures also look the same. But why don't we have connection here? Because we are not at all feeding the input x of n to the summing point directly. We are feeding x of n minus 1, x of n minus 2 and x of n minus 3 to the adder. So, there is no connection from this point to this adder, clear. So, this is about the direct form 1 realization. Now, let us see how to draw direct form 2. Now, let us start drawing direct form 2 structure. I have taken h of z. I have written it by taking it z cube as a common factor both in numerator and denominator. Now, we know h of z is nothing but equal to y of z by x of z. To this, in direct form 2, we introduce a variable w of z divided by w of z, which can be written as w of z by x of z into y of z by w of z. This is nothing but our h1 of z into h2 of z. So, what is h1 of z? h1 of z is nothing but equal to w1 of z by x of z divided by x of z, which is equal to 1 divided by 0.5 plus 0.3 into z power minus 1 plus 0.17 into z power minus 2 plus 0.2 into z power minus 3. Now, what let us do? I need to find out the expression for w of z. So, let us cross multiply this with this with 1. So, if I write the expression, it is 0.5 into w of z plus 0.3 into z inverse into w of z plus 0.17 into z power minus 2 into w of z plus 0.2 into z power minus 3 into w of z, which is equal to x of z, correct. Now, I want only the expression for w of z. So, let us move rest of the term towards right hand side. So, that will be equal to 0.5 into w of z, which is equal to x of z minus 0.3 into z power minus 1 into w of z plus minus 0.17 into z power minus 2 into w of z minus 0.2 into z power minus 3 into w of z. Now, I wanted only w of z in the left hand side. So, let us move 0.5 towards right hand side and let us check the equation for w of z. So, this is the equation which we get once we move 0.5 towards right hand side. To this equation, let us apply inverse z transform. Then, w of n will be equal to 2 into x of n minus 0.6 into w of n minus 1 minus 0.34 into w of n minus 2 minus 0.4 into w of n minus 3. So, we completed the simplification of h1 of z. I need to perform the same procedure for h2 of z. If I do so, what is h2 of z? We know h2 of z is nothing but equal to y of z divided by w of z, which is equal to the numerator expression, that is 0.28 into z power minus 1 plus 0.319 into z power minus 2, and the last one is plus 0.04 into z power minus 3. Now, what let us do? Let us cross multiply. Therefore, y of z will be equal to 0.28 into z power minus 1 into w of z plus 0.319 into z power minus 2 into w of z plus 0.04 into z power minus 3 into w of z. We got the expression for y of z. Now, let us apply inverse z transform and find out the expression for y of n. So, apply inverse z transform. So, the expression will be y of n, which is equal to 0.28 into w of n minus 1 plus 0.319 into w of n minus 2 plus 0.04 into w of n minus 3. We got two different equations, one for h1 of z and other for h2 of z. With the help of this difference equation, let us start drawing the structure. First let us take up this one. Here the output is W of n and the input is X of n. So take input X of n and multiply X of n with 2 and give it to an adder. So take this, multiply that with 2, give it to an adder. Then giving all the elements to the adder gives us W of n. So the output of this adder will be W of n. Okay. What is the second term? It is nothing but the delayed version of W of n multiplied with minus 0.6. So let us delay this once. Gives us W of n minus 1. So multiply this with minus 0.6 and give it to an adder. Moving on to the next term, again W of n minus 2 is nothing but the delayed version of W of n minus 1. So delay this again once, gives us W of n minus 2. To this W of n minus 2, what should I multiply? Minus 0.34. So to this multiply minus 0.34, give it to an adder, connect the output of this adder to the top adder. The last term is nothing but W of n minus 3. So delay W of n minus 2 once, gives us W of n minus 3. So multiply this with minus 0.4, multiply this with minus 0.4 and give it to this adder. So this completes the structure of H1 of Z. Now I should continue the structure for H2 of Z. Here W of n is acting as input and Y of n is acting as output. So here we don't have W of n term. So nothing is going from W of n term to this adder, which gives us the output Y of n. So the first element is nothing but the delayed version of W of n. So if I delay W of n once, gives us W of n minus 1. To this I should multiply 0.28. So to this multiply 0.28 and give it to an adder, connect the output of this adder to the top adder. Then the next term is W of n minus 2. So here we have W of n minus 2, multiply this with 0.319 and give it to an adder and connect the output of this adder to the top adder. Finally, we have W of n minus 3, we already got W of n minus 3, multiply this with 0.04. So multiply this with 0.04 and connect it to the top adder. So this is nothing but the direct form 2 realization for the given transfer function. So this is how we can solve problems related to direct form 1 and 2. So this completes the realization of IIR filter.